Today we start Chapter 9 dealing with exponential functions. Something that I would like you to do as we graph through numbers 1 and 2, I would like you guys to write in your journal, y equals a times b to the power of x. Y equals a times b to the power of x. I'll rewrite it right down here. The letter A is going to let you know your initial value, where you're starting. Okay? The B value is going to be considered the growth or the decay factor. So it's going to be considered the growth or decay factor. It's considered to be a growth factor if the B value ends up being greater than 1. It's considered to be a decay factor if the B value is less than 1 but greater than 0. So any fraction between 1 and 0 is going to make things significantly smaller every single step. So you're going to be dealing with either growth or decay. So right here, if we take this and apply this to the first problem, this is our A value, this is our B value. This is our A, this is our B. Something that's really important. If you see a formula that looks like this, anytime you start with 0, it will always be 0, comma, A every single time. So right here, if I say 0, what's my A value right here? 1.5. The number 2, do you think that's a growth or a decay? That is a growth. It's a growth factor by a factor of 2. Now check this out. If x goes up 1, what's double 1.5? 3. What's double 3? So everything's growing by a factor of 2 every single time. Well, what's half of 1.5? That's going to be 0.75. And half of 0.75 is 0.375. So if I go down 1 and go down another, this is what your table should look like. Now everybody may not have used these points, but these points are definitely a part of this exponential function. Now I'm going to graph it. I'm going to graph a negative 2 and a 3.75, which is maybe not that low. Maybe more like right here. Negative 1 and a 0.75, 0 and a 1.5, 1 and a 3, 2 and a 6. And you can see that this graph exponentially grows by a factor of 2. So that's your graph for number 1. Now, and number 2, you can't plot the points on number 2, except you can plot 0 and then your A value, which is 4. No, you can't. 1 is 12. Why is it 12? Because our growth factor is a factor of 3. And 2, that would jump all the way up to a 3. So this, guys, you can see how these right here are jumping up by factors of 3. Now, if I go backwards, all right, negative 1, I got to divide that by 3 or multiply it by a third. And if you multiply it by a third, you get 4 over 3, which is 1.3 repeated. If you multiply this by a third, you get 4 over 9, and that's the 0.4 repeated. And that's at negative 2. So at negative 2, you're at 0.4, which is really close to 0.5. Negative 1, you're at a 1.3. 0, you're at a... by the way, an accurate graph of this would be a graph that goes through these points, and you better not cross where x is equal to a 1. Because at 1, where should you be at? 12. So I would mark this answer wrong if your graph looked like this. If you said, Mr. Mood, I drew an exponential function, I'm like, yeah, you did, but you didn't draw the one that was right here. Now, these were both growth. All right? These exponential functions both dealt with growth factors. We're going to go over here. This one does not deal with a growth factor. This one deals with a decay factor. So I'm going to put 0. Where are we starting? 0 what? 0, 3. Very good. Now, 0.5 is like saying taking a half of something, right? What's half of 3? 1.5. And then we know half of 1.5 is 0.75, and half of 0.75 is 0.375. Now, if these are all being halved, if I go backwards, then what do I do with the 3? I would go double, right? What's double that? And -2, what's double this? There we go. So without using the graphing calculator, you can actually figure out how to plot an exponential graph if you know this is your A value, right? And this is your B value. And this one dealt with what? It dealt with not growth, it dealt with decay. So right now I'm going to plot -1, 1, 2, 3, 4, 5, 6, 0, 3, 1, 1.5, 2.75, and 3.37. And then you can see that this sucker goes down, 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 over. Just do your best to go through the points. There we go. And it gets closer and closer and closer. Now, the one thing that it also asks you to do is to state the domain and the range. So everybody, for the domain, for all of these, I want you guys to write the domain are all of your x values, but all real numbers. Okay? All real numbers. Your range, all of your y values, every single y value, is greater than 0. It's not equal to 0. All of your y values are greater than 0. It's never going to cross over this x-axis. By the way, that's the answer for all three. Your domain is all real numbers, and your range is y is greater than 0. Whether it's growing or whether it's decaying, you still have the same domain and you have the same range. All of your y values are greater than 0. All of your x values are being plotted. All right, now that we have this, you guys are going to be determining whether these equations are growth or decay. Now, you probably figured out number 4 is decay because that's a fraction. What fraction is 0.6? That's 3 bits, right? That's between 0 and 1. And you probably figured out that number 5 is growth because that number 2 is bigger than 1. Number 6 is a little tricky. Let's look at number 6. That's the part that gets kind of tricky. So right now, what do you guys think your A value is? That's just a 5. But sometimes students think the B value is 4, but it's actually not 4. But -1 times x. Does everybody agree that -1 times x is a negative x? If I have 4 raised to the power of -1, that's the same thing as this, everybody. 4 raised to the power of -1 is the same, right here, using the same equations. You guys know that 4 to the 0 is 1. You know that 4 to the first is 4. You know 4 squared is, well, 16. 4 to the -1 and 4 to the -2 means 1 over 4, and this is 1 over 4 squared, which is 1 over 16. So 4 to the negative 1 is actually 1/4. So that one was kind of tricky. So actually, if x is positive, which x has to be, when you're plugging numbers in, you're plugging in positive values for x or negative values for x, but you want this to be a positive value of x. Now you know what your b value is. Now you know what your a value is. So check this out. I'm going to hit y equals. I'm going to type in 5 parentheses 4 close parentheses raised to the power of negative x. And I'm going to hit the graph button. Now if you guys look at the graph, you can see that that's a decay. It's going what? It's going down. Now I realize that this graph looks like it touches 0, but if you zoomed in, it really wouldn't be touching 0. It would be really, 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 really close to it. If I hit y equals 5, parentheses, 1 divided by 4, close parentheses, raised to the power of x, what should happen? You see a trace over? Okay, so those are the exact same graph. So what does that tell you about this? That tells you this is not a growth. It is a decay. It's not growth, it's decay. The last thing we're going to do today is we're going to show you how to build an equation. We're going to put problem number 9 in your journal. So go ahead and put problem number 9 in your journal. And when you start this problem, write y equals a times b to the power of x. All right, what we're going to do right now is we are going to take these two ordered pairs and we're going to find the exponential function that goes with these two ordered pairs. Something we talked about at the very, very beginning of this video was if you have a 0, that is going to be your a value. So what I'd like you to do first is write y equals -3, open parentheses, b raised to the power of x. That's the first one. The next thing we're going to do is I'm going to highlight this number in blue and this number in red. This represents an x coordinate. This represents a y coordinate. So I'm going to take the y coordinate and plug it in here. I'm going to take the x coordinate and plug it in there. My y coordinate is -1.5. My x coordinate is 1. If I divide both sides by -3, -1.5 divided by -3 is a half. So 1/2 is equal to what? B to the power of 1. That's right. So right now, we just found our b value. So b to the power of 1 is b. That's what b to the power of 1 is b. So our final answer is y equals, what was our a value to start out? -3. What was our b value? 1/2 raised to the power of x. That is the equation that goes through both of these points. Now, what I'm going to do is I'm going to show you that it goes through 0, -3, and 1, -1.5. So I'm going to go to my graphic calculator, hit y equals. I'm going to clear that out. Clear that out. I'm going to type in -3, open parentheses, 1 divided by 2, close parentheses, raise that to the power of x, check my table, and what should I see in my table? And there they are, right there. If you see them, you know you did it correctly. And that one was an easy one. Let's do a slightly more difficult one, okay? This will be the last problem that we did. Let's see here, let's go down and do, let's do number 12. Here's the final one we're going to do. 0, a, x, y. Our a value is pi. Our x value is 3. Our y value is 8 pi. So I'm going to start with the equation. Y equals A times B to the power of X. All right, so what am I going to plug in for A? What am I plugging in? What am I going to be solving for? Solving for B. Now, after you plug that in, I simply want you to take right here, take the 3 and plug it in right here, take the 8 pi and plug it in right there. So we have 8 pi equals pi times B raised to the power of 3. Divide both sides by. Pi's will cancel each other out. 8 is equal to a number raised to the power of 3. So some number in the world raised to the power of 3 is the number 8. Now this one you can probably do in your head. But let's say you can't do it in your head. What could you do? What is the reciprocal of 3? You could apply a power of 1/3 to this side and a power of 1/3 to this side. So your B value will be whatever 8 raised to the power of a third is equal to. So you have a graphing calculator to help you out with that. So let's say you're like, I don't want to use a graphing calculator. 8 is 2 to the third power. 3 times the third is 2, just so you know. B is equal to 2. You don't believe me? It's okay. Understand. Sometimes math teachers aren't believable. But 8 to the power of 1/3 is 2. So what is your final answer in the form of Y equals A times B to the power of X? Pi, parentheses, what number am I plugging in? 2. That's it. What's your final?